Okay, so welcome to the project Fast and Furious in NYC. So our project pointing to exploring the patterns, trend, and the risk factors in NYC vehicle crashes. So we're using two data sets, both from the NYC Open. And the first one, the primary data set we're using is the NYC motor vehicle collisions, and the supplementary data set we're using is the NYC traffic volume. And the research question we have is like, when do collisions most frequently occur, and where do crashes occur, and which boroughs exhibit the highest risk? And for the rest, we just like how serve our collisions and how do injury pattern vary across the NYC, and like which environmental factors to do with the car crashes, and also like which contributing factors associates with the injuries. And our website structure basically include the homepage and about the data page, exploratory analysis. The one is the overview, and the another one is the time trend. And we also have the mapping, modeling, correlations page, and there's a final page called project reports that include our project report. So let's move to the data. So the data source we have, the primary data source we have is the motor vehicle collisions crashes that published by NYPD via the NYC Open Date. And we have the links and the units of observations and those key variables we all like listing here. And the rest of them is just like how we import data and do the data cleaning. So what we do is like we delete some variables and delete the NA value. And also we pivot the time to the right like to the right format. And also we create some like supplement variables. And after that, we save the clean data. And here's the overview of our clean data. And those are the variables we're gonna use for the analysis. And that's the information for yeah, and following that is this data set we use to supplement our correlation part. Yeah, and that's it.
Okay, so starting here with the exploratory overview, this page like gives a broad sense of how the motor vehicle collisions are distributed across New York City. So as I scroll down, you can see the summaries that highlight which place experience the most crashes and how injuries severity breaks down and the general structure of the dataset. And this section sets the foundation for the understanding the patterns we analyze later. Yeah, you can see here by hour of day and by day of week. Um, and for the now moving to the time trend module, this is where we look at the how collisions change over time. As I scroll down through the plot, you can see the long-term trends from the 2012 to 2024, including the key shifts such as a decline during the 2020 pandemic and the um, and the potential changes in 2014. We also examine the seasonal patterns and compare the trends across the different injury severity levels. And these visualizations help us to identify the when collisions are most likely to occur and whether the safety is improving over time. Yeah, and finally in the mapping module, we visualize where the collisions occur across the city. As you can see on the map, um, the Brooklyn and the Queens consistently show the highest concentration of the crashes, and while the certain areas in Manhattan appear as a hot spot, and this special perspective complements the time trends and give us a more clear understanding of the both where and when collisions risk are highest. Yeah, so we move on to the modeling.
Okay, so for the modeling part, we analyze the injured and also the death reason of the crashes. So first of all, we did some pre-processing. We transferred our variable to the digital one, and therefore we can use it. So we use both the linear regression and also the Poisson regression to analyze the injury reason, and we compare both models and did a residual diagnosis. And after that, we did a death reason. We want to find out what contribute to the death cases. Uh, and here's what we've done in the modeling parts. Generally, the linear model and Poisson model, and after that, the death reason. And for the correlation part, we add the traffic volume dataset to do a correlation analyze. And in our data, we find out that the traffic volume and crash counts only have very weak positive relationship. On the citywide, the Pearson correlation is about 0.1, which means volume alone explain only about 1% of variation in crashes. So overall, the traffic volume by itself cannot explain when where the crashes happen. Other factors such as road design or intersection density, speed, and also we have like contribution such as overspeeding could more contribute to the crashes.
Yeah, so here's our project report page, and I'm gonna start with our first part is our motivation that covers what was on our homepage, and we go over the goals and research questions. Yeah. And basically the project report covers everything we have, like a summary of our website. And here it includes the two primary data set is the model vehicle collision data, and then the other one is the traffic volume data that we use for the correlation. And here's like a overview of all the exploratory analysis that we go over earlier. Yeah. And here in the additional analysis part, we have the two mapping that we have from the previous pages that shows that the mapping shows like how severe the collisions happen and where it mostly happens. Yeah. And for the modeling part, we'll include the linear regression, Poisson regression, and the two model comparison in our modeling section. And here's our final discussion that we answer our research question that we think um, it follows the strong daily and weekly pattern, and also the collision and it happens by like a geographic variation across the five boroughs, and also the collision severity indicates that most crashes are involved from property damage only from our mapping. And finally, our modeling work like shows the which factor are associated with the injury outcomes. Yeah, so here's everything of our website.